Hello students, welcome to your channel Parivartan Physics. See, we are in the series of videos where we are going through a course called as KCET 2025 Rapid Revision course. In this videos, we are revising all the concepts, shortcuts and formulas of each chapter in a go, right? So here, you already ಎರಡು videos ಈ playlist ಒಳಗೆ upload ಆಗಿದಾವೆ. One is electric charges and fields and then electric potential. ಅದರದ್ದು ಒಂದು video upload ಆಗಿದೆ. So this is in this video we are going to see about capacitance and capacitors, right? In this video, see, I have already solved KCET PYQs on each chapter, right? 5 years, 7 years, 8 years, 10 years. ಈ ತರ ಪ್ರತಿ ಚಾಪ್ಟರ್ ಮೇಲೆ KCET PYQs ಗಳನ್ನ ನಾನು ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀನಿ. ಆ KCET PYQs ಗಳನ್ನ ಸಾಲ್ವ್ ಮಾಡಿದ ವಿಡಿಯೋಸ್ ಕೂಡ ನಿಮಗೆ ಈ ಚಾನೆಲ್ ಒಳಗೆ ಅವೈಲೇಬಲ್ ಅದಾವ. The link of that playlist is available in the description, right? So you can go there and you can watch the videos of KCET PYQs, right? Okay, next. As I had told you, ನಾ ನಿಮ್ಗೆ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್ ಒಳಗೆ ಹೇಳಿದ್ದೆ, ಇಲ್ಲಿ ನಾ MCQs ಸಾಲ್ವ್ ಮಾಡ್ತಿರಂಗಿಲ್ಲ. ನಿಮ್ಗೆ MCQs ಬೇಕಾದ್ರೆ ನಾ ಅದಕ್ಕೆ ಒಂದು PDF ನಿಮ್ಗೆ ಪ್ರತಿ ವಿಡಿಯೋದಕ್ಕೆ ಲಿಂಕ್ ನಾ ಕೊಡ್ತೀನಿ ಅಂತ ಹೇಳಿದೆ. ಸೊ ಫಸ್ಟ್ ವಿಡಿಯೋ, ಐ ಮೀನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಅಂಡ್ ಫೀಲ್ಡ್ಸ್, in that video's description I have added the PDF of MCQs on electric charges and fields, right? So electric charges and fields ಗೆ CET ಬೇಕಾಗಿರುವಂತ MCQs ಏನದಾವಲ್ಲ, you don't think that these are the important MCQs. There is nothing like that ki important questions for CET, important MCQs for CET ಆ ತರದ್ದು ಏನೂ ಇರಂಗಿಲ್ಲ. CET ಗೆ ಒಳಗೆ ಈ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಸ್ ಒಳಗೆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಏನು ಇರಂಗಿಲ್ಲ. ಇಂಪಾರ್ಟೆಂಟ್ ಇಸ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್, ರೈಟ್? ಸೊ ನೀವು ಕಾನ್ಸೆಪ್ಟ್ಸ್, ಫಾರ್ಮುಲಾಸ್, ಶಾರ್ಟ್ಕಟ್ಸ್ ಎಲ್ಲ ಗೊತ್ತಿರಬೇಕು. different questions solve ಮಾಡ್ಕೊಂತ ಹೋಗಬೇಕು. That is all what you have to do, right? So PDF is available in the description box of that video, electric charges and fields, first video. And for the next video, electric potential and capacitance, I will add it shortly. So for every video I will add a PDF of MCQs related to that concept in that description box. You can go and download that PDF. ಆಮೇಲೆ ಆ PDF ಒಳಗೆ ನಿಮಗೆ ಕ್ವೆಶ್ಚನ್ಸ್ ಅಷ್ಟಲ್ಲ, ಅದರ ಸೊಲ್ಯೂಷನ್ಸ್ ಕೂಡ ಇರ್ತವೆ. So you can practice those questions. Fine. Let us continue then. We'll start with capacitance and capacitor. Okay, capacitance of a conductor. Capacitance of a conductor is given by C is equal to Q by V. C is equal to Q by V. And we know very well the SI unit of capacitance is farad. SI unit of capacitance is farad, right? Okay. Then capacitance of a conductor depends upon size, shape and surrounding medium of that conductor. A conductor's surrounding medium size ಮತ್ತು shape may depend ಆಗ್ತದೆ. Next, capacitance of a spherical conductor, right? This is a spherical conductor whose radius is r and charge on that is q. So the capacitance of a spherical conductor is 4 pi epsilon naught r. Here c is directly proportional to the radius of that spherical conductor. If radius increases, capacitance increases. Okay, next, capacitance of a parallel plate capacitor. See, here we have taken a parallel plate capacitor in which there is air present in between the plates of the capacitor. In between the plates of the capacitor there is air. So air capacitor, the capacity estadappa andre epsilon naught A divided by D. This is the capacity of the air capacitor. Air capacitor means there is nothing other than air in between the plates of the capacitor. Next, completely filled capacitor. See, completely filled capacitor means in between the plates of the capacitor we have substituted a dielectric medium whose dielectric constant is K. So in that case, the capacitance will become C is equal to K epsilon naught A divided by D. We have to multiply the dielectric constant to that air capacitor's capacitance, right? So what is epsilon naught A divided by D? That is air capacitance. So K into C naught. So by inserting the dielectric, what happened? The capacity got increased. How many times it got increased? K times it got increased. Capacity increases K times. ಸೊ ನೀವು ಯಾವುದೋ ಒಂದು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಮೀಡಿಯಂ ಅನ್ನು ಕೆಪಾಸಿಟರ್ ಪ್ಲೇಟ್ಸ್ ಮಿಡಲ್ ದೊಳಗೆ ಹಾಕೊಂಡ್ರಿ ಅಂತಂದ್ರೆ ದ ಕೆಪಾಸಿಟಿ ಆಫ್ ದಟ್ ಕೆಪಾಸಿಟರ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್. ಹೌ ಮೆನಿ ಟೈಮ್ಸ್ ಇಟ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್? K times it will increase. So capacitance of air capacitor, capacitance of completely filled capacitor. Okay, next we'll see capacitance of partially filled capacitor. Partially filled means it is not completely filled from one plate to another plate. See, here we have taken a parallel plate capacitor in which we have substituted a dielectric whose dielectric constant is K and the thickness of that dielectric is T. I am not saying that the thickness of the dielectric is exact the half of the distance between the plates. Plates ನಡುವೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಐತೆ ಅದ್ರ ಹಾಫ್ ಐತೆ ಅಂತ ಹೇಳತ್ತಿಲ್ಲ. ಎಷ್ಟೋ ಒಂದು thickness ಅದರಿ. It may be less than half also, it may be greater than half also. Okay, that much is dielectric. Other than that, what we are having? Other than that, we are having air here, right? Air gap. We are having air gap here. Air is also dielectric only, whose dielectric constant is 1, right? Okay, so the distance between the plates is D. In such case where there is air gap, partially filled capacitors ಒಳಗೆ air gap ಇರುವಂತ capacitors ಒಳಗೆ effective capacitance, ಆ capacitance of that capacitor ಎಷ್ಟು ಆಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ epsilon naught A divided by d minus t. This distance is d minus t. Air ಒಳಗೆ ಏನು distance ಅದಲ್ಲ, that is d minus t. D minus t plus t by k. Effective distance of this will be t by k. Epsilon naught A divided by d minus t plus t by k. Right? D minus t plus t by k. That will be the capacitance of this partially filled capacitor. Okay, next, if a metal is introduced, if ನೋಡ್ರಿ, if ಇಲ್ಲೇ ಈ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ನಾವು ಇಲ್ಲೇನು ಹಾಕೊಂಡಿದೀವಲ್ಲ, ಈ ಜಾಗದೊಳಗೆ ಸಪೋಸ್ ನಾವು ಮೆಟಲ್ ಹಾಕೊಂಡ್ವಿ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. What is the dielectric constant of metal? It is infinity. Dielectric constant of metal. So if I insert a metal here, then this t by k, in place of k I have to substitute infinity, because dielectric constant of metal is infinity. So anything by infinity will be 0. This term becomes 0. That's why the formula will be epsilon naught A divided by d minus t. If it is dielectric, d minus t plus t by k. If it is metal, it is d minus t only. Next, if the thickness of that metal plate, if the thickness of this metal, the thickness enadru, if it is d by 2, half of the distance between the two plates, ಆ ಎರಡು plates ನಡು exactly half ನಾವು metal ಹಾಕೊಂಡಿದ್ವಿ ಅಂತಂದ್ರೆ, if we have put the metal, then it will be d minus d by 2. See, in place of t I have to take d by 2, so it will again become d by 2. D minus d half will be d half. That 2 will come to the numerator. What is epsilon naught A by d? It is air capacitance. So capacity will get increased 2 times. Right? Double either capacity. One capacity becomes double when the distance between the two plates is half filled with a metal. Half distance new metal ಹಾಕೊಂಡ್ರಿ ಅಂದ್ರೆ ಅದರ capacity double ಆಗ್ತದೆ. Right? So this is all about partially filled capacitors. Next, these both are completely filled capacitor only. ಈಗ ನಾವು ಪ್ರೀವಿಯಸ್ ಕೇಸ್ ಏನು ನೋಡ್ಕೊಂಡಿದ್ವಿ, ಅದು ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಐತ್ರಿ. ಪಾರ್ಷಿಯಲಿ ಫಿಲ್ಡ್ ಅಂತಂದ್ರೆ ಏನು, ಇಲ್ಲೂ ಏರ್ ಗ್ಯಾಪ್ ಅದ, ಇಲ್ಲೂ ಏರ್ ಗ್ಯಾಪ್ ಅದ್ರಿ. ಬಟ್ ಹಿಯರ್ ದೇರ್ ಇಸ್ ನೋ ಏರ್ ಗ್ಯಾಪ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, ದೇರ್ ಇಸ್ ನೋ ಏರ್ ಗ್ಯಾಪ್. But we have filled the capacitor completely. But there are 3 different dielectrics in between that plates. ಈಗ ಮೊದಲು ಏನಿತ್ತಲ್ಲ, ಇದು ಒಂದು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಇತ್ರಿ. There was only one dielectric here. It is completely filled, but there is only one kind of dielectric. Okay, here you can see the gap between the two plates is completely filled, but there are 3 different dielectrics. 1, 2, 3. There are 3 different dielectrics. Dielectric constant of first one is K1, K2, K3. Thickness of the first dielectric is T1, T2, T3. Then how much will be the effective capacitance? Epsilon naught A divided by T1 by K1 plus T2 by K2 plus T3 by K3. Here what has happened? Due to the dielectrics, the distance between the plates has got divided in 3 parts: T1, T2, T3. So the distance has got divided here. When the distance between the plates is divided by the multiple dielectrics, here we can say there are 3 capacitors which are connected in series. Now 3 capacitors in series ಒಳಗದಾವ ಅಂತ ನಾವು ಅನ್ಕೋಬೇಕು. Then the effective capacitance will be epsilon naught A divided by thickness of the dielectric by its dielectric constant, T1 by K1 plus thickness of second dielectric by its dielectric constant, T2 by K2 plus T3 by K3. Like this we have to take it. Right? So this is when the distance is divided by the multiple dielectrics. Second case, if 2 dielectrics are filled, that is T1 is equal to T2 is equal to D by 2 ಅಂತಂದ್ರೆ ನೋಡ್ರಿ, 3 ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಹಾಕೋ ಬದಲು 2 ಡೈಎಲೆಕ್ಟ್ರಿಕ್ಸ್ ಹಾಕೊಂಡ್ರು ಅಂತ ಇಟ್ಕೋರಿ. K1 and K2 ಹತ್ರದ ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅದ, in such a way that thickness of the first dielectric is D by 2, thickness of the second dielectric is D by 2. It means in the first half 1 dielectric of dielectric constant K1, in the second half 1 more dielectric of the dielectric constant K2. If such dielectrics are inserted in between the plates, then at that time it will become epsilon naught A T1 andre ಎಷ್ಟು D by 2 by K1 plus T2 means how much? D by 2 by K. So simplifying this, we will get the final answer like this: epsilon naught A by D 2 K1 into K2 by K1 plus K2. So if there are 2 dielectrics in between the plates of the capacitor, you directly go for this formula: epsilon naught A by D 2 K1 into K2 by K1 plus K2. If there are more than 2, then you go for this. This is the basic formula. If there are 4, then you have to add one more term here, plus T4 by K4. If there are 5, add one more quantity, plus T5 by K5. Like this, we have to go on solving it. So this is the fundamental basic formula. But ಎರಡು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಇದು ಮ್ಯಾಕ್ಸಿಮಮ್ ಬಹಳ ಸರಿ ಈ ತರದ್ದು ಕೇಳ್ತಿರ್ತಾರೆ. ಸೊ ಇದಕ್ಕೆ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫಾರ್ಮುಲಾ ಅಂತ ಹೇಳಿ ಇದೊಂದು ಸಿಂಪ್ಲಿಫೈಡ್ ಫಾರ್ಮೆಟ್ ಅದ್ರಿ. ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಿಸ್. ಓಕೆ, ವೆಲ್, ಸೊ ಹಿಯರ್ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಡನ್, ವಿ ಹ್ಯಾವ್ ಫಿಲ್ಡ್ ದ capacitors with multiple dielectrics in such a way that distance is getting divided here. Area divide ಆಗತ್ತಿಲ್ಲ. ಏರಿಯಾ ನಮಗೆ ಎಲ್ಲ ಕೆಪಾಸಿಟರ್ಸ್ ಏರಿಯಾ ಎ ಅಂತ ಹೇಳಿದ್ರಿ. ಏರಿಯಾ ಎ. Distance is getting divided. Distance T1, T2, T3 ಒಳಗೆ divide ಆಗತ್ತೆ. Okay, next we'll again fill the capacitors with 3 different dielectrics, but this time the distance is not getting divided by the dielectrics. Distance between the plates another, it is not getting divided. What is getting divided? Area is getting divided. A1, A2, A3. 3 dielectrics are there, K1, K2, K3. In this case, the effective capacitance will be epsilon naught by D, A1 into K1 plus A2 into K2 plus A3 into K3. Right? There it was epsilon naught A divided by T1 by K1 plus T2 by K2 plus T3 by K3 when the distance is divided by the dielectric. When area is divided, A1 K1 plus A2 K2 plus A3 K3. Right? Okay, next, if instead of 3, if 2 dielectrics are substituted in between the plates of the capacitor such that first dielectric is in half area and second dielectric is in half area. Half of area ಒಳಗೆ ಎರಡು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಹಾಕೊಂಡ್ರೆ ಅಲ್ಲಿ ಹೆಂಗೆ ಹಾಫ್ ಆಫ್ ಡಿಸ್ಟೆನ್ಸ್ ಒಳಗೆ ಎರಡು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಹಾಕೊಂಡಿದ್ವಿ ಹಂಗೆ ಹಾಫ್ ಆಫ್ ಏರಿಯಾ ಒಳಗೆ ಎರಡು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ನಾವು ಏನಾದರೂ ಹಾಕೊಂಡ್ರೆ then it will be epsilon naught A by D K1 plus K2 by 2. Right? So it's simplified form of it. There it was epsilon naught A divided by D into the bracket 2 K1 into K2 by K1 plus K2. Here it is epsilon naught A by D K1 plus K2 divided by 2. Correct? Okay, so when 2 dielectrics are substituted. Fine. So this is all about completely filled capacitors. Okay, next, I have taken an example here. ಸ್ವಲ್ಪ complicated ಇದ್ದದ್ದು ತಗೊಂಡಿದ್ದೀನಿ. However, I am going to solve only one. That's why. Okay, see, these are the plates of the capacitors, and the distance between the plates of the capacitors is D. And there are 3 dielectrics filled here. This is first, this is second dielectric, and this is third dielectric. Totally 3 dielectrics are there. First dielectric has occupied a area of A by 2. The area occupied by the first dielectric is A by 2. Area occupied by the next 2 dielectrics is A by 2. Correct? Distance or thickness of the first dielectric is D. And thickness of the second dielectric is D by 2. Third dielectric is D by 2. Right? You half of distance. Right? So here we have to write the capacitance, effective capacitance between A and B. How many capacitors are there? 3 capacitors are there because 3 dielectrics are filled. 3 capacitors are there. Right? This is C1 and this is C1, this is C2, this is C3. What I had told you, if distance is divided, then the capacitors are said to be in series. Distance divided agidre capacitors series olagada vandange. If area is divided, then the capacitors are said to be in parallel. Correct? So here C2 and C3, these both are in series because they are dividing the distance. So C2 is in series with C3. Right? This combination is in parallel with C1 because they are dividing the area. So they are in parallel. Okay, we got to know the combination. Now note down the values of C1, C2, C3. Okay, if I want to write the value of C1 is C antandre epsilon naught A by D. If dielectric is there, K epsilon naught A by D. Right? So capacitance of the first capacitor, I mean it will be K1 epsilon naught. How much is the area of that capacitor? It is A by 2. Area is A by 2. K epsilon naught A by 2 divided by what is the distance? Distance is D. Correct? So I can write this as K epsilon naught A divided by 2D. K epsilon naught A divided by 2D, or simply I can write it as K C naught by 2. C naught andre air capacitor capacitance, epsilon naught A by D. So this is C1. Similarly C2 calculate ಮಾಡ್ಕೋಬೇಕಾದ್ರೆ C2 ನೋಡ್ರಿ, C2 the dielectric constant 3, ಇಲ್ಲಿ 4 ಕೊಟ್ಟಿದ್ದಾರೆ, K1 is 4. So if I substitute K1 here, if I substitute the value of K1 here, right, 4. So if this I take it as 4, so this is 4 C naught by 2, it will be equal to 2 C naught, right? This much I will get. Next, second capacitor. What is the dielectric constant of the dielectric which is present in the second capacitor? It is 3. How much is the area? A by 2. How much is the distance? D by 2. Correct? So what I will get? I will get it as dielectric constant K2 into epsilon naught into the area is A by 2 into the distance is D by 2. Correct? So here what happens, this 2 and this 2 will get cancelled. I will get it as K2 epsilon naught A divided by 2. Sorry, epsilon naught A divided by D. Epsilon naught A divided by T. So this will be K2 into C naught. How much is C naught? Sorry, K2 into C naught. How much is K2? K2 is 3. So this will be 3 C naught. 3 C naught. C2 I C3. Check about C3 now. C3. So C3 is K3 into epsilon naught. How much is the area of C3? A by 2. A by 2. How much is the distance? D by 2. Right? This 2 and this 2 will get cancelled. You will get it as K3 epsilon naught A divided by D. Right? What is the value of K3? It is 6 C naught. Correct? So we got the values of C1, C2 and C3. According to the combination, you have to find out the effective capacitance now. C2 and C3 are in parallel, which is in, are in series, which is in parallel with C1. So I will find the effective capacitance of C23. C23, it will be C2 into C3 divided by C2 plus C3. Correct? How much is C2? C2 is 3C0. 3C0 into 6C0 divided by 9C0. Divided by 9C0. 3 1s are 3 3s are 3 1s are 3 2s are C0 and C0 will get cancelled. You will get 2C0. 2C0. Next, C23 under this combination, this series combination is in parallel with C1. It is in parallel with C1. So the effective capacitance between AB will be equal to C23 plus C1. How much is C23? It is 2C0. How much is C1? It is 2C0. It is 2C0. So total capacitance will be 2C0, 4C0. C0 under new matte epsilon naught A by D anta tagobodu. Right? This much will be the answer of this. Clear? Okay, let us go to the next concept now. See, here we are going to see about the combination of drops. See, combination of drops antandre illi enagirtade, there are small drops here, and each drop is having charge Qs, capacity Cs, voltage Vs, energy Us, charge density sigma S. ಈ ಚಾರ್ಜಸ್ ಈ ಎಲ್ಲ ಡ್ರಾಪ್ಸ್ ಗಳನ್ನು ಕಂಬೈನ್ ಮಾಡಿ ನಾವು ಒಂದು ಬಿಗ್ ಡ್ರಾಪ್ ಫಾರ್ಮ್ ಮಾಡ್ತೀವಿ. Okay, so by combining the small drops, we are going to form a big drop. So the charge of this big drop is QB, capacitance is CB, VB, UB, sigma B. So they will ask you, these many drops are given. If you combine them, what will be the charge of the big drop or charge of the small drop? Charge density, energy, capacitance, they will ask you. So for that, you have to remember these formulas. E formulas in you and charge of big drop will be equal to n raised to 1 times of charge of small drop. Capacitance of big drop, cube root of n of Cs. Charge density of big drop, cube root of n of Cs. Voltage of big drop, n raised to 2 by 3 times of voltage of small drop. Energy of big drop, n raised to 5 by 3 times of energy of small drop. Right? So like this we will get combination of drops. So you have to remember these formulas. Drops combination will question bandre ee formulas nu nenpettukore, within a step you will get the answer. Okay, next, a dielectric is inserted between the plates of a capacitor. One parallel plate capacitor da athara nodi dielectric hakondidare. Once the battery is connected and once more the battery is disconnected antandre it is like this. Here there is a parallel plate capacitor where the dielectric is inserted, whose dielectric constant is K, and for this the battery is connected. Idak battery connected adare, right? Battery connected. In the second case, the same capacitor is there with the dielectric whose dielectric constant is K, but this time there is no battery connected. Battery is disconnected. So what happens in this case? Dielectric insert ಮಾಡಿ ಒಮ್ಮೆ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಇಟ್ಟು ಒಮ್ಮೆ ಬ್ಯಾಟರಿ ನೀವು ತೆಗೆದ್ರಿ ಅಂತಂದ್ರೆ ಏನಾಗ್ತದೆ? ಸಿ ಇಲ್ಲೇ ನಾವು ಯಾವಾಗ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟೆಡ್ ಇಡ್ತೀವಿ ಮತ್ತು ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಅನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ, no doubt in both the cases, if you insert the dielectric, capacity has to increase K times. Capacity ನಮಗೆ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಇರಲಿ ಇರದೇ ಇರಲಿ, ಡೈಎಲೆಕ್ಟ್ರಿಕ್ ಹಾಕೊಂಡ್ರೆ ಕೆಪಾಸಿಟಿ ಅಂತೂ ಇನ್ಕ್ರೀಸ್ ಆಗ್ಲೇಬೇಕು. ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಇದ್ದಾಗ ಏನೇನು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತವೆ? ಚಾರ್ಜ್ ವಿಲ್ ಇನ್ಕ್ರೀಸ್ K times, capacity will increase K times, and potential energy will increase K times. Energy of that capacitor will increase K times. But electric field and potential, these will remain same. So these three will increase K times. You increase ಆಗ್ತದೆ. Battery disconnect ಮಾಡಿದ ಕೂಡಲೇ ನೋಡ್ರಿ, charge will remain same. It will not change. Charge remains same. It will not change. ಇಲ್ಲೇ ಇವೆರಡು ನಮಗೆ ಸೇಮ್ ಉಳಿತಿದ್ರಿ, ಚೇಂಜ್ ಆಗ್ತಿರ್ಲಿಲ್ಲ. ದೀಸ್ ಬೋತ್ ವೇರ್ ರಿಮೈನಿಂಗ್ ಸೇಮ್ ಹಿಯರ್, right? Here only charge is remaining same. Capacity, it got increased k times. Rest of the three will decrease k times. That's why we have taken it as u naught by k, e naught by k, v naught by k. So k times you decrease ಆಗ್ತಾವ್ರಿ. So these three have got decreased k times, and here these three have got increased k times by connecting the battery. This is what happens when a dielectric is inserted and a battery is connected, a battery is disconnected, right? Remember this. We'll go to the next concept. Sorry. Okay, capacitors in series and capacitors in parallel, right? Basically ನಿಮಗೆಲ್ಲ ಗೊತ್ತಿರುವಂತದ್ರಿ. So these are in series, these are in parallel. Capacitors series ಒಳಗಿದ್ರೆ what will be same? Charge will be same. Voltage gets divided. Voltage ನಮಗೆ divide ಆಗ್ತದ್ರಿ, V1 V2, right? Charge will be same, Q and Q, C1 and C2. Effective capacitance when two capacitors are in series, C1 into C2 by C1 plus C2. When three capacitors are in series, C1 into C2 into C3 divided by C1 into C2 plus C2 into C3 plus C3 into C1, right? Divided by identical capacitors. Not divided by. Identical capacitors idre CS is equal to C by N. Identical capacitors. Similarly, when capacitors are connected in parallel, voltage is same, charge gets divided. Itrad reverse ರೀ. ಇಲ್ಲೇ charge same ಇತ್ತ, voltage divide ಆಗಿತ್ತೆ. ಅಲ್ಲಿ voltage same ಅದ, charge divide ಆಗ್ತದ್ರಿ. Effective capacitance will be C1 plus C2 if three capacitors, C1 plus C2 plus C3. If identical capacitors, N into C. Identical capacitors in parallel, N into C. Identical capacitors in series, C by N. Right? You remember this. Okay. How to find the combination? ಕೆಲವೊಬ್ಬರು combination find ಮಾಡೋದು tough ಅನಿಸ್ತಿರ್ತದ್ರಿ. So I will tell you a simple way. Here, if you want to know the combination, ಇಲ್ಲಿ ಬರೀ ನಾ combination ಹೇಳೋ ಸಲುವಾಗಿ ತಗೊಂಡಿದ್ದೇನೆ ಅದನ್ನ. See, if they are asking you the effective capacitance between A and B, then in between these 2 points a battery is connected anta artha. There is a battery connected in between these 2 points, right? Yav ಎರಡು points nadu nimage effective capacitance ಕೇಳಿರ್ತಾರೆ, there you have to connect a battery. Okay, a charge q will be given out from this battery. ಈ battery dagin charge q ಹೊರಗೆ ಬರ್ತದ್ರಿ, right? So this charge q will pass through C1. It will pass through C1, right? This charge q will pass through C1. Okay, it will pass through C1, and after coming to this junction, e junction ಬಂದ ಕೂಡಲೇ it is having two paths further. ಎರಡು path ಅದಾವ, right? So this q will get divided in two parts, q1 and q2. It will get divided in two parts. So q1 will pass through C2 and it will come here. q2 will pass through C3 and it will come here. They both will get added and again q will pass through this. Again q will pass through this. Correct? So ಈಗ ನಾವು series combination ಅಂದ್ರೆ ಏನ್ ಸೇಮ್ ಇರಬೇಕಂತ ಹೇಳಿದ್ವಿ? Charge must be same. Parallel combination andre charge must be different, voltage must be same. If charge is same, they are in series. If charge is different, they are in parallel, right? Ille charge yavrolage same ada, C1 ಒಳಗೆ ಮತ್ತು C4 ಒಳಗೆ charge Q ಅಂತ ಹೇಳಿ ಸೇಮ್ ಅದ. They both are in series. What about C2 and C3? They are having different charges, Q2 in this, Q1 in this, so these both are in parallel. So here the combination is like this. ಇಲ್ಲಿ combination ನಮಗೆ ಈ ತರ ಅದ. C2 is in parallel with C3. C2 is in parallel with C3. And this combination is in series with C1 as well as it is in series with C4. As well as it is in series with C4. So these both are in parallel. This parallel combination is in series with C1 and it is in series with C4. So ಇವ ಎರಡು C1 ಮತ್ತು C3 ಕೂಡಿ ನೀವು ಇದನ್ನ ಒಂದೇ ಕೆಪಾಸಿಟರ್ ಅಂತ ತಗೋಬಹುದು. ಆ ಕೆಪಾಸಿಟರ್ ಒಳಗೂ ನಮಗೆ Q ಅಂತ ಹೇಳಿ ಚಾರ್ಜ್ ಪಾಸ್ ಆಗ್ತಿರ್ತದ್ರಿ. Q Q Q. It will come like this. So charges are same in C1, effective C and C4. So they are in series. ಅವು ನಮಗೆ series ಒಳಗೆ ಅದಾವ. Okay, ಇಲ್ಲೇ see again you have to think there is a battery connected in between A and B. The charge is supplied here at point A and it will come out here at point B. So this charge after coming to this point it will get divided in two parts. ಇದನ್ನ Q1 ಅಂತ ತಗೊಳ್ರಿ, ಇದನ್ನ Q2 ಅಂತ ತಗೊಳ್ರಿ, ಇದನ್ನ Q2 ಅಂತ ತಗೊಳ್ರಿ. So Q1 will pass through C2, Q2 will pass through C1. This Q1 after coming to this junction again it will get divided in two parts because there are two paths further. So that's why this will be Q3 and this will be Q4, correct? So Q4 will pass through C4 and Q4 will pass through C5, right? And it will come here. The Q4 will come here. Q3 will pass through C3 and that Q3 will come here. So Q3 and Q4 will add. Q3, Q4, Q2, all these will add. Here we are getting Q2 and again we will get Q outside. ಇಲ್ಲಿ Q enter ಆಗಿತ್ತೆ, ಇಲ್ಲಿ Q ನಮಗೆ ಹೊರಗಡೆ ಬಂತ. Right? Which capacitors are in series? If charge is same, series. If charges are different, parallel. Okay, so here C4 and C5, these are in series because charge in this is Q4, charge in this is Q4. ಇವೆರಡು ನಮಗೆ series ಅದಾವ್ರಿ. And charge in C3 is different. Here it is Q3, here it is Q4. right? So iವೆರಡು ಕೂಡಿ ನೀವು ಇದನ್ನ ಈ ತರ ತಗೋಬಹುದು. You can take it like this now, right? Together these both together you can take it as one capacitor. ಇದನ್ನ ನೀವು ಒಂದು ಕೆಪಾಸಿಟರ್ ಅಂತ ತಿಳ್ಕೊಬಹುದು, right? You can take it as one capacitor. It is the capacitance of C4 and C5. So these both are in parallel. ಇವೆರಡು ನಮಗೆ parallel ರೀ, ಯಾಕಂದ್ರೆ ಇದ್ರೊಳಗೆ ನಮಗೆ ಚಾರ್ಜ್ Q4 ಇತ್ತು, ಇಲ್ಲಿ ಚಾರ್ಜ್ Q3 ಅದ. ಚಾರ್ಜಸ್ ಆರ್ ಡಿಫರೆಂಟ್, so they are in parallel. Okay, this combination is in series with C2. This combination is in series with C2, and whole this square is in parallel with C1. Whole this square is in parallel with C1, correct? So here two capacitors were there, they were in series. That series combination is in parallel with C3, and that triangle is in series with C2, and this square is in parallel with C1, right? This is how we have to find the combinations. Okay, next. Ille nodri, this circuit I have taken just to make you understand how the voltage will get divided, how the charge has to be calculated, how the voltage has to be calculated, how the effective capacitance has to be calculated. Mainly voltage division, right? So ಇಲ್ಲಿ ನೋಡ್ರಿ, ನಾವು ಏನೇನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗಿದೆ. We want to calculate effective capacitance, we want to calculate charge on each capacitor, we want to calculate voltage across each capacitor. Everything we have to calculate here. Okay, there is a 12-volt battery, 4 microfarad, 8 microfarad. There are 3 capacitors. Combination ನಿಮಗೆ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗ್ತದೆ. C2 and C3 are in parallel. C2 and C3 are in parallel. So parallel ಅಂತಂದ್ರೆ add ಆಗ್ತಾವ್ರಿ. add ಆದ್ರೆ ಇದ್ರದ effective ಎಷ್ಟು ಐತ್ರಿ? 12 microfarad. So here I will draw that circuit now, simplified circuit. So ಅವು ಎರಡು ಕೂಡಿ ಒಂದೇ ಕೆಪಾಸಿಟರ್ ಅಂತ ತಗೊಳ್ರಿ, right? So it will get simplified like this. So this is of 12 microfarad. 4 plus 8, right? I will take it as C23. Idu C23, 12 microfarad, right? This is C1, 4 microfarad, right? So it got simplified like this now. Okay, batteries of 12 volts. Now these both are in series. ಎರಡು series ಒಳಗದ ಒಂದ ಮೇಲೆ ಚಾರ್ಜ್ ಸೇಮ್ ಇರ್ತದೆ, but voltage gets divided. Let the voltage across first capacitor be V1, and let the voltage of the across C23 be taken as V2, right? V2 plus V1 will be equal to 12 volts. ಇದು 12 volt ನಮಗೆ ಡಿವೈಡ್ ಆಗಿರ್ತದ್ರಿ. It may get divided in 4 and 8, it may get divided in 6 and 6, it may get divided in 7 and 5. ಆ ತರನು ನಮಗೆ ಅದು ಡಿವೈಡ್ ಆಗ್ಬೋದು. So how, on what basis it gets divided? ಆ ವೋಲ್ಟೇಜ್ ನಮಗೆ ಎത്ര ಬೇಸಿಸ್ ಮೇಲೆ ಡಿವೈಡ್ ಆಗ್ತದ್ರಿ? See, capacitance is equal to Q divided by V. Capacitance is equal to Q by V. In series, charge will be same. That's why capacitance is inversely proportional to voltage. More the capacity, less the voltage. Less the capacity, more the voltage. In this way, in the reverse order of capacity, the voltage gets divided, right? Okay, let us see how to find that voltage now. A voltage ಯಾವ ತರ find ಮಾಡಬೇಕು? So to find out that voltage, you take the ratio of the capacitors. C1 is to C2 ಅಥವಾ then C34 ಅಂತ ತಗೊಳ್ರಿ. C1 is to C23 is equal to, okay, this is 4 micro, this is 12 micro. So I will write it as 4 is to 12, or we can simply take it as 1 is to 3. Correct? Since capacity is inversely proportional to voltage across first capacitor, voltage across second capacitor, I will write it as 3 is to 1, because these both are inversely proportional. So you will flip and write it here. So if you want voltage across first capacitor, then the corresponding value of V1 is 3 divided by 3 plus 1, 4 into the total voltage. How much is the total voltage? It is 12. So 4 ones are 4 3s are 3 into 3 will be 9 volt. Correct? So V1 is equal to 9 volt. See, out of 12 volt, if you have got here 9 volt, then rest of the voltage will be here. It is 3 volt. Correct? So 9 plus 3 will be 12. ನೀವು ಬೇಕಾದ್ರೆ calculate ಮಾಡಿ ನೋಡ್ರಿ. V2 corresponding value of V2 is how much? 1 divided by sum of ratio 3 plus 1 4 into the total voltage. 4 ones are 4 3s are. So the voltage is 3 volts. So you got voltage. So you got to know how the voltage gets divided here. Voltage ಯಾವ ತರ ಡಿವೈಡ್ ಆಗ್ತದೆ, voltage ಎಷ್ಟು ಬಂತು ಅಂತ ಗೊತ್ತಾಯ್ತು. 9 volt 3 volt. Okay, you got capacitance, you got voltage. If you know C and V, you can calculate Q. Q is equal to C into V. So charge on the first capacitor, Q1 will be 9 into 4, 36 microfarad. If the capacitor on the first capacitor is 36 microfarad, on this capacitor also it has to be 36 microfarad only, because these are in series. Series ಒಳಗೆ ನಮಗೆ charges same ಇರ್ತದೆ. So here it is 36, here it is 36. But this is not one capacitor, this is two capacitors in parallel. So the entire charge of these two capacitors is 36 microcoulomb. But what happens in parallel? Parallel ಒಳಗೆ ಏನಾಗ್ತದ್ರಿ? Charge will be same or charge will get divided. Parallel ಒಳಗೆ charge divide ಆಗ್ತದ್ರಿ. Okay, so to find out the charge on C2 and C3 separately, ಈಗ ಇದ್ರ ಮೇಲಿನ voltage ಗೊತ್ತಾಯ್ತು, charge ಗೊತ್ತಾಯ್ತು. See, voltage here is 9 volt, voltage here is 9 volt, and charge here is 36 microcoulomb. This much is the charge. Sorry, ಇದು coulomb, right? This is coulomb, not farad. 36 microcoulomb. Okay. Next note, voltage is 3 volt. ಇಲ್ಲೇ ನಮಗೆ C23 ದ voltage 3 volt ಬಂದದ್ರಿ. 3 volt ಬಂದದ್ದು. It is 3 volt. So since these both are parallel, the voltage will be same. Voltage ನಮಗೆ ಸೇಮ್ ಇರ್ತದ್ರಿ, ಎರಡು parallel ಇರೋದ್ರಿಂದ. Right? So this is C, this is V. Q is equal to C into V. So charge on third capacitor will be equal to C3 into 3. So 8 into 3, 24 microcoulomb. 24 microcoulomb. Correct? And charge on second capacitor will be 4 into 3, 12 microcoulomb. Correct? This much will be the charge. Right? So charge on second. So 12 plus 24, it will be 36. Right? Total charge ನಮಗೆ ಇಷ್ಟು ಇರ್ತದೆ. That's how we have to calculate what charge on each capacitor and voltage on each capacitor. Effective capacitance ಕೇಳಿದರೆ, effective capacitance ನೋಡ್ರಿ, ಇವೆರಡು parallel ಅದಾವ, it will become 12. ಇವೆರಡು ನಮಗೆ series ಅದಾವ. So the effective capacitance will be equal to C1 into C2 divided by C1 plus C2. It means 4 into 12 divided by 4 plus 12, 16. 4 ones are 4 4s are 4 ones are 4 3s are. So the effective capacitance is equal to how much? Effective capacitance is 3 microfarad. This much is the effective capacitance. Clear? Okay, this is how we have to understand the circuits. Okay, that's all about the combination of circuits. Next, energy stored in a capacitor is given by U is equal to half CV square. This energy is electrical energy. This is electric energy. This is electric energy which is stored in the form of electric field. It is stored in the form of electric field in between the plates of capacitor. In between plates of capacitor. Right? So half CV square is the electric energy in between the plates of capacitor. Half Li square is the magnetic energy which is stored in the solenoid ಅಥವಾ coil ಒಳಗೆ store ಆದಂತ energy ಅದು. So this is electric energy stored in the form of electric field in between the plates of the capacitor. Energy density. Energy density means it is energy stored per unit volume. And the formula for energy density is half epsilon naught E square. Half epsilon naught E square. Right? So remember the formulas. Okay, let us go to the next concept and say common potential. ಇಲ್ಲಿ common potential ಹೋಗಕ್ಕಿಂತ ಮುಂಚೆ ನೋಡ್ರಿ, for example, if there are two capacitors, let me say this is C1 is first capacitor and we are having one more capacitor called as C2. We have charged the first capacitor for 100 volt and we have charged the second capacitor for 50 volt. Itrad potential difference 100 ada, itrad potential difference 50 ada. So when there is potential difference between the capacitors, charge will flow from higher voltage capacitor to lower voltage capacitor. Charge ನಮಗೆ ಇಲ್ಲಿ ಶೇರ್ ಆಗ್ಲಿಕ್ಕೆ ಶುರು ಆಗ್ತದ್ರಿ. So this charge transfer takes place from higher voltage capacitor to lower voltage capacitor until the voltage of the first capacitor becomes equal to the voltage of the second capacitor. When the voltage of both the capacitors become equal, that is called common potential. ಅದು common potential ಅಂತ ಕರೀತಾರೆ. So ಆ common potential find ಮಾಡ್ಲಿಕ್ಕೆ ನಮಗೆ ಇರುವಂತ ಫಾರ್ಮುಲಾ ಇಲ್ಲಿದೆ. Right? When positive plate of one capacitor and positive plate of second capacitor, negative and negative, positive and positive are connected, common potential will be C1 V1 plus C2 V2 divided by C1 plus C2. Common potential. If the plates are interchanged, positive negative negative positive, then simple ಆಗಿ ಇಲ್ಲಿ middle ದಾಗಿಂದ ಒಂದು sign change ಮಾಡ್ರಿ, that's it. C1 V1 minus C2 V2 divided by C1 plus C2. Right? So these are the common potentials. Next, ಈ charge share ಆಗಬೇಕಾದ್ರೆ there will be loss in energy. So energy loss is calculated by using this formula. Half C1 into C2 by C1 plus C2, V1 minus V2 whole square. This is energy loss in this case. Correct? Okay, we'll go to the next concept then. See, this is plates. ಈ plates ಮೇಗೂ ಬಹಳ ಸಾರಿ questions ಬಂದಿರ್ತಾವೆ. So how to find the effective capacitance here? Yes, effective capacitance. ಯಾವ ತರ effective capacitance find ಮಾಡಬೇಕು? ಇಲ್ಲಿ ನೋಡ್ರಿ, how many plates are there? 1, 2, 3, 4. 4 plates are there. 3 capacitors will get formed. If there are n plates, n minus 1 capacitors will get formed. 4 plates are there, 3 capacitors. 5 plates are there, 4 capacitors. 10 plates are there, 9 capacitors. Like this, right? So ಇಲ್ಲಿ 3 capacitors form ಆಗ್ತವೆ. This is the first capacitor, second capacitor, and this is the third capacitor. How to find the effective capacitance? All plates will be of same area. Distance between all plates will be same. ಈ ಕೇಸ್ ಒಳಗಡೆ ಈ ತರ parallel plates ಬಂದ್ರೆ. Okay, see, the first plate is connected to A, so I will name it as A. Second plate is connected to B, so I will name it as B. Third plate is connected to A, so I will name it as A. This fourth plate is connected to B, I will name it as B. First plate is in between first capacitor. This is first capacitor. First capacitor is in between A and B. Second capacitor is in between A and B. third capacitor is in between A and B, right? So the combination will be like this now. This is A and this is B, right? First capacitor in between A and B, correct? Second capacitor in between A and B, second capacitor. Third capacitor in between A and B, third capacitor. So all three capacitors are in parallel, right? All three capacitors in parallel. So if the capacitors are connected between same 2 points, if the capacitors are connected between same 2 points, then they are said to be in parallel. Okay, so how much will be the effective capacitance? See, all are identical capacitors, C. So the effective capacitance between A and B will be identical capacitors in parallel, N into C. So this will be 3C. So the effective capacitance is 3C. Okay, you come here. How many plates are there? 1, 2, 3, 4, 5. How many capacitors will get formed? 4. This is first, this is second, this is third, and this is fourth. These are the 4 capacitors. Okay, this plate is A, this plate is B, this plate is A, this plate is B, right? So this plate is connected to A, so I have taken it as A, this one as A, this one as B, this one as B. This plate is neither connected to A nor it is connected to B, so take it as X. Adine X anta tagodre. Okay, see, first capacitor is in between A and B, second capacitor in between A and B, third capacitor in between A and X, fourth capacitor is in between B and X, correct? So in between A and B there are 2 capacitors. In between A and X there is 1 capacitor. In between X and B there is 1 capacitor, right? So we'll simplify the circuit now. This is point A and this is point B. This is point B. First capacitor is in between A and B. First capacitor is in between A and B. Second capacitor is also in between A and B. Second capacitor is also in between A and B. This is first and this is second capacitor. Third capacitor is in between A and X. So A ಮತ್ತು B ನಡು ನಮಗೊಂದು point ಅದ. This is A, this is B. There is one more point called as X. So third capacitor is in between A and X. So here I will take the third capacitor. This is third. Fourth capacitor is in between B and X. So here I will take the fourth capacitor. Correct? So this is third capacitor. This is fourth capacitor. Okay. Now, ನೀವು ಅಥವಾ ಇದನ್ನು ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ ಈ ತರನು ತೆಗಿಬಹುದ್ರೆ. Okay, let it be. Okay, so these both are all capacitors are identical here. All capacitors are identical. What will be the effective capacitance of this? 2C. What will be the effective capacitance of this? C by 2, because these both are in series. Iveradu series dav, iveradu parallel dav. Then what is the 2C and C by 2 combination? These both are parallel, 2C and C by 2. So effective capacitance between A and B will be 2C plus C by 2, which will be equal to 5C by 2. Right? This much will be the effective capacitance between A and B. Clear? Okay. So that's all. Okay. Here we have some more. Okay. Ille nodri. Ille mattond case ade. This is A, this is B, this is B, and this is A. See, ille this capacitor is connected between B and B only. If a capacitor is connected between the same point, then this is said to be short-circuited capacitor. You just don't consider it. Adin biಟ್ಟು ಬಿಡ್ರಿ. Short-circuited capacitor. You just forget it, right? So it is a short-circuited capacitor. So ಇಲ್ಲಿ ನಮಗೆ ಎರಡು capacitor ಬರ್ತಾವ್ರಿ. One is in between A and B. This is the second one. So this is also in between A and B. This is also in between A and B. It means 2 capacitors are in parallel. So the effective capacitance between A and B will be 2C. Okay, here you come. See, ee tara bandaga, see, this is a wire. So wire is connected from this point to this point directly. So if this is A, this is A. Idu wire idre ashta ನೀವು ಇದು A ಇದ್ರೆ ಇದನ್ನು A ಅಂತ ತಗೋಬಹುದು. ಇಲ್ಲಿ ಮಿಡಲ್ ದಾಗ ಏನಾದರೂ ಕೆಪಾಸಿಟರ್, ರೆಸಿಸ್ಟರ್, ಇಂಡಕ್ಟರ್ ಏನಾದರೂ ಕನೆಕ್ಟ್ ಇದ್ರೆ you cannot take this point as A. You cannot take it as A. Right? Okay, this is B, then this is also B. So this is first capacitor, second capacitor, third capacitor. First capacitor is connected between A and B, second capacitor between A and B, third capacitor between A and B. It means all 3 capacitors are connected between A and B only. So they are said to be in parallel, hence the effective capacitance will be 3C. Right? Common potential method anta karitare idಕ್ಕೆ. ಇವೆಲ್ಲ ಸರ್ಕ್ಯೂಟ್ಸ್ ಬಗ್ಗೆ ನಾನು ಡೀಟೇಲ್ಡ್ ವಿಡಿಯೋ ಮಾಡಿ ಹಾಕಿದ್ದೀನಿ ರೀ. I have put a detailed video on this chapter on capacitors. So you can find NEET and KCET electrostatic potential and capacitance playlist. In that, this chapter I have taught in a very detailed way. 22 videos are there, right? So you can watch if you need any concept very clearly. You can watch there. I solved number of MCQs also, right? Okay, so that's all about. Okay, that's all about this video, right? Capacitors and capacitance. Dear students, hope you have understood the concepts and remember the formulas. Study well and do your KCET greatly, right? Dear students, see, as I have told you already, In case the chapters are big, I will make 2 videos on that chapter. Otherwise, I will complete one chapter in one video only. In next video, I will complete current electricity completely. So current electricity one the video mugisbidteni. So per day one chapter is getting over, right? So I can complete your second PUC chapters in 10 or 12 days. I can complete it, right? So in namaga fast hogtavare, in mundin chapters alla fast hogtave. So in one video I will complete one chapter. So if this is helpful, please tell your opinion and please share the video, share the channel with your friends, and please subscribe and support the channel, right? So thank you so much for watching and supporting this channel. Please keep watching and supporting the channel, right? If you need anything else, please put a comment. Many of you were asking me to do one shot MCQs videos, I mean solving MCQs in a video. I will try to do those videos also, but let me complete this series first, right? So ee series na completely model ಮುಗಿಸ್ತೀನಿ. ಅಂದ್ರೆ ಎಲ್ಲಾ ಚಾಪ್ಟರ್ ಮ್ಯಾಗಿಂದ ಈ ರ್ಯಾಪಿಡ್ ರಿವಿಷನ್ ಕೋರ್ಸ್ ನಾವು ಇದನ್ನ ಫಸ್ಟ್ ಮುಗಿಸೋಣ. ಇವೆಲ್ಲನೂ ನೋಡ್ರಿ. ಆಮೇಲೆ ನಿಮಗೆ ನಿಮ್ಮ ಹತ್ರ ಆಲ್ರೆಡಿ ಯಾವ್ದಾದ್ರು ಬುಕ್ಸ್ ಇರ್ತಾವೆ, ಸಾಲ್ವ್ ದೋಸ್. ಅದರ್ವೈಸ್ however I am giving you number of questions also for every video. So watch that video and solve those MCQs. It will give very good maturity to solve the MCQs on KCET questions, right? So it will help you. And as you all are requesting for the MCQ video, I will do that, but let me complete this series first. ಆಮೇಲೆ MCQs videos ಗಳನ್ನು ನಾವು ನೋಡ್ಕೊಳ್ಳೋಣ. ಎಷ್ಟು ಪಾಸಿಬಲ್ ಅದ ಅಷ್ಟು ನಾನು ಮಾಡ್ತೀನಿ, right? As much as possible, pulling out the time from my schedule, I am doing the videos. So please don't get disappointed if I don't do any video or something like that. If the video get delayed or something like that, please don't get disappointed. I will try to do maximum whatever help I can do for you all, right? Thank you so much. Please keep watching and please keep supporting your channel Parivartan Physics. Thank you so much.